This is 2013 question 6. Based on this setup, I know that this is a slope fields separable differential equations type of problem. Right away I see particular solution, so that's what drove me there. There is no slope fields here, but this tells me right away that when we get to part B, that's probably where the majority of our points are going to go. Okay, so here we go. We'll go in order. They give us dy dx, and here we go. Write an equation for the line tangent to the graph of f at point 1, 0, then use this tangent line to approximate. So reiterating, like with all the previous videos, if you want an equation of a tangent line, this pops up so often, okay? You need two things. You need a point and a slope. They already give you a point. All you need is a slope. So you have to understand that slope is really just derivative. In this case, it's dy dx. So if I plug in 1 and 0 in, just like the scoring guidelines, you guys will get something like -3. You could leave it as equals, but that's pretty straightforward enough to do, okay? So now that this is your slope and you have a point, you just need to put it into point slope form, which is y minus y1 equals the slope times x minus x1. Okay? That is your equation there. Equal is equal. There's no need to simplify. Okay, so just keep that in mind. Now, they do ask you to follow up to approximate f of 1.2. So you kind of do have to get y by itself here. Normally, we would add the value over, but 0 is really just 0, so there's no need to do that. So you're ending up with something like this. Okay? All we have to do is plug in 1.2. And equal is equal, you leave it there. Okay? And there you go, 3 easy points. So easy. Here we go. The last part, particular solutions. I'll jump straight to it. We have dy over dx equals e to the y times 3x squared minus 6x. So remember, in this setup, the y's have to stay on the left. So in this case, I would have to multiply the dx on over. And then on the right side, I have a y term here, e to the y. So I'm going to have to actually divide by that e to the y over to the other side. Okay, let me cross out those. So on the left, I actually have 1 over e to the y dy, but I'll write it as e to the negative y dy. On the right side, I'll have 3x squared minus 6x dx. Okay? You got to know how to separate. If you can't separate, you're pretty much forfeiting the remaining 5 or 6 points. Okay? So make sure that you guys always rewind, go back if you need to have something repeated. Okay? If I integrate this now, the right-hand side will be 3x cubed over 3 minus 6x squared over 2. Okay? It's up to you if you want to simplify it. I'll leave that up to you guys to answer. On the left side here, there is a function inside of another function. It's kind of like that last problem in 2012 where you had a negative linear at the bottom. You could go back to that video if you'd like. But pretty much there is a function inside of your exponential function. One way to just combat this is to just use mental U substitution. So here we go. The derivative of negative y is -1. And then you take the reciprocal of that, which is really just -1 again. So you know you're going to have a -1 on the outside of your answer. And the rest you just integrate. How do you integrate e? It stays the same, e to the negative y. Okay? That should give you an extra 2 points, along with the 1 point for separating, okay? The fourth point is putting that plus c right there, okay? That'll give you your constant of integration. Now, here we go. So What you want to do now is the moment you've integrated, you want to find out what c is, okay? So they give you a condition. They tell you that it passes through 1, 0, meaning that x is 1 and y is 0. So I'm going to plug that in for you guys. Negative 1 times e to the negative 0 equals 3 times 1 cubed over 3 minus 6 times 1 squared over 2 plus c. Equal is equal. You could leave everything bare and just move everything away from c, but this is simple enough for me to do. E to the 0 is just 1, so you're left with a negative 1 on the left side. 1 cubed is 1. 3 over 3 is just 1 minus 6 over 2, which is just 3. So here I should get negative 2. So that should give me positive 1 if I solve for c. Okay? So I'm going to go back because I don't have space. I know that c is positive 1. I plug that back in. Now on the AP exam, don't go erasing it, just putting a plus 1. Okay? It's just because I don't have enough space. The last step, remember, we separate, we integrate, and then we isolate. Okay? You're just getting y by itself. This is where it gets a little bit messy. So I'm going to group this entire thing, okay? But I'm not going to write everything out. So what I'm going to do is I'm going to divide by a negative 1. So all I have left is e to the negative y equals blah over the negative 1. So everything inside that green stuff, I'm just going to write there. Now remember, my only goal is to get y by itself, okay? So I'm going to natural log to get rid of that e. So now, negative y will equal the natural log of that blah over negative 1. Okay, it's messy, but it's equal. So let the AP readers do all the hard work here. So last step, we're going to divide by another negative 1 to get y by itself. So y will equal the natural log of blah over negative 1 all over negative 1. Okay, obviously the scoring guidelines cleaned everything up. Really, you don't have to, okay? Because you don't get extra points for simplifying. Just keep that in mind, okay? It doesn't matter how clean it looks. As long as it's equivalent, you guys are going to get your points there, okay? And that's it. Remember, practice particular solutions. That's where the majority of your points are going to be, so you want to maximize on that, okay?